Now we are going to go through the proof of the classification theorem. The first step in the proof is realizing that every surface can be actually expressed or represented by a plane model. So a plane model is a polygon with labels on its edges that indicate how we are supposed to glue edges together. So now, while I'm going to skip the main process of cutting the surface into triangles and assembling them back together, I just want to emphasize the fact that the same surface always has a lot of different plane models that represent it. So let me give you an example. So suppose that first we begin with the surface, and then we cut it into triangles, and then we remember how we are supposed to glue the triangles back together. And then after we glue all the triangles back together, so in the end we get a polygon with an even number of edges, so that these edges are labeled according to how they are supposed to be glued. Well, let me just give you one example of what we may have. So suppose that we cut our surface into two triangles that look like this. This is going to be A, C, B. Right? And this is going to be C, A, B. Well, it means that it is possible to recover the original surface from these two triangles by just gluing C to C, B to B, and A to A. But this is not a plane model yet. So a plane model is a single polygon. Now, how can we construct a plane model out of this? So the first way to do it is to glue this triangle to this triangle according to C. So let me write that this is going to be triangle number 1, and this is going to be triangle number 2. And then if I glue them like this, so suppose that I am putting them together, so this is my C. I glued them along C. So this is my A, this is my B, this is my A, and this is my B. Now, once I glued along C, it means that I don't really have to remember it anymore, so I can just erase it. And what I got is this thing. So A, B, B. So by the way, this surface is called the plane model. Plane model. Well, but this is not the only way to glue these triangles together. So, for example, the alternative way to do it, let me do it like this. So I'm going to put triangle number 1 in the bottom. So this is going to be triangle number 1. So I'm going to just copy it. This is C, this is A, and this is B. And then I'm going to put to glue it to triangle number 2 along B. But notice that here B points to the left, and here B points to the left. So that if I want them to fit together, I have to flip this triangle, right? So when I'm gluing them, I'm going to flip it, turn it over, so that B actually points to the left. But then when I flip it, of course, A is going to be on the left now, and C is going to be on the right. So this is triangle number 2. Now, if I'm gluing them back together, so this is what I'm going to get. So now I'm putting them together, so this is going to be my B. But since I've glued along B, I don't really need to remember this B anymore. So this is going to be A, this is going to be A, this is going to be C, and this is going to be C. Well, now maybe a couple of remarks. Remember that the labeling on edges, it is needed for us to be able to recover the original surface. So for instance, if I rename C to B, it doesn't matter. So as long as this edge is glued to this edge, it is enough. So whether it is C, B, or I don't know, X, Y, Z, it doesn't matter. So the actual label doesn't matter. So as long as this edge and this edge, they have the same label. So which means I can just rename it. Another thing is that the direction matters, again, only when you compare it to the direction of the other label. But if we reverse both arrows at the same time, it is still the same direction of gluing. So, which means that what I can do here, I can reverse the direction of A. Now it goes clockwise, so I can reverse it to be counterclockwise. I'm going to put it like this, AA. And then I'm going to rename C to B. So this is going to be B, and this is going to be B. Right? And this is another version of the same surface. This is because, you know, both of them, in both cases, we had our original surface, then we cut it into two triangles, and then we just, you know, we just use the labels to recover the original surface. But the way to put it together could be different. I mean, of course, the original surface is still the same, but it's going to have two different manifestations or representations as a plane model. Right? So it means that this and this are two different plane models for the same surface. So they, or we can say that they are homeomorphic. So this is the Klein bottle, and this is the sphere with two cross caps. All right. I hope it's clear, so that a surface can have different ways to represent it with a plane model.